All right, we're going to be solving meeting rooms 2. This is a LeetCode medium right up there. So let's dive in. I'm going to do this one quickly. Similar to the meeting rooms 1, except for instead of merging them, we're going to be returning the minimum number of conference rooms required. So we're given an array of intervals, start time and end time, and we want to return the amount of meeting rooms that we can use. So first, edge case scenario. If the intervals is null or the intervals length is 0, then we don't need any rooms. Uh, so what we're going to want to do is we're going to want to sort the arrays, obviously, based off their start times. We can have them in order. We're going to use a lambda expression. So if you remember, comma, parentheses, 2 parameters, add the arrow, and then you have the custom comparator here. So we're just going to be comparing the start times, which is the 0 index element, as you can see here. That's good. So now we've sorted it. Now we want to use we're going to use a priority queue or a min-heap to store the end times. This way, um, the last meeting is stored in there, so we can iterate through and compare the earliest ending meeting for the current meeting, since we've sorted it. So we'll do that. And then we want to iterate through them. We'll go array by array, meeting by meeting. Okay. And we're going to do a check here. We want to see if the min heap is not empty. So if the min heap is not empty, then we want to go inside and see what the earliest ending meeting is. So, and we want to make sure that the earliest ending meeting, the end time is less than or equal to the start time of the next meeting. So basically what we're doing is we've sorted the intervals. So we have them sorted by beginning time onward. And then we're utilizing a priority queue to hold the end times. And pretty much we're just going to be comparing what's on the priority queue, which is showing you the earliest ending time. We're going to compare that with the sorted list of the start times. So that way we can tell if the rooms have been if the meeting's done, then we don't need to, add another room. And the priority queue, the size of the priority queue will be holding the amount of rooms that we need. So we'll use the peak function. And we want the peak, this is going to be the end time. So that if the end time is less than or equal to the next meeting start time, then we're going to add it. Or we're going to remove the meeting because the meeting's done. So we can move that other meeting in there. Whoops. Min-Heap dot poll. Sorry. And now we'll add the current meeting's end time to the heap. So basically we're just iterating through and comparing these end times with the begin times of the sorted array. And if we have some that are concurrent, it'll get added onto that queue and stay down there. And so at the end, we'll know how many rooms that we need. Then just return min-heap dot size. Let's check and see the syntax. Okay, and so this is n log n for time complexity because we're using a priority queue, and the space should be O of n. Yep. And so that's how to utilize a priority queue. And I'll just go over the concept again. First, we're sorting the intervals array based off the start time. Then we create a priority queue to hold the end times of the intervals. Priority queues are min heaps, and min heaps have the property of putting the minimum element at the top. So when you poll it, it removes the minimum element. So we've sorted the array based off the start time, and then we're going through and we're adding in the meeting's end time and comparing the meeting's end time with the next meeting start time. And we're adding that in, and the min-heap does a great job of handling that. Good luck. Keep on.